Today we're going to be learning about linear functions. So the first topic we're going to be learning about is system of equations. A system of equations is a set of collection of equations that you deal with all together. There are two different types of equations, one with 3 variables and one with 2. There are 3 different ways to solve a system of equations. These include elimination, substitution, and graphing.
Elimination. First example is with 2 variables right here and here, and the second example is with 3 variables here, here, and here. For the first example, you would want to multiply the first equation by 5 so that you can subtract it to this variable from this, and then you get negative 17. In this problem, it means that there's no unique solution. In other words, there's no solution. The same thing with 3 variables, except these have solutions. Substitution. These same example, 2 variables and 3 variables. First, you solve for the y in the first equation, then you want to solve for the x, and then you can plug it in back to solve. And this, you would want to do the same thing for the 3 variables.
Okay, so graphing. You can only use this method when you have equations with 2 variables. So first you want to graph your 2 equations, and then you want to solve for the solution. You can use any of the previous ways of solving that we looked at before. So in the end, your solution is where the 2 lines intersect. System of inequalities. A system of linear inequalities in 2 variables consists of at least 2 linear inequalities in the same variable. So here we have our 2 examples. So the first thing you want to do is to graph the 2 inequalities. First graph the boundary lines, then decide on which side of each boundary line contains solutions and whether the boundary lines are included. Shade in the area and find your solution area.
Distance word problems. A distance word problem involves something traveling at a fixed speed or else moving at some average speed. Example. A boat makes a 36-mile upstream trip on a river in 9 hours. The returning trip takes 6 hours. Find the speed of the boat in still water and the speed of the current. Write 2 equations and solve. Since the distance is the same both ways except one's faster and one's slower, you want to plus and subtract from the current so you can find this current speed, and then you have your speed of the boat in still water.
And investment problems. Investment word problems usually involve simple annual interest as opposed to compound interest. So our example is Bernie has saved $3,200 from a part-time job, and he wanted to invest his savings in a growth fund, income fund, and a market fund. The percent return fund is growth fund, 10% income fund, 7%, and money 5%. To maximize his return, Bernie decides to put twice as much money in the fund as in the money fund. How should Bernie invest the $3,200 to get a return of $250 income of the year? So here your 3 variables are growth, income, and money, and you can use any of the ways of solving that we looked at. You can use substitution, elimination, or graphing. So here we have the continuation of the problem and the answer of each growth fund. So our answer is he should invest $650 in the money market, $1,300 in the growth fund, and $125 in the income fund. Distance formula. So the distance formula we use is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So you want to plug the numbers if you have your 2 sets of points. You want to use y2, so this is y2 and y1 and x1 and x2. Plug those into the distance formula and you should come out with a radical. So you want to put your answer in simplest radical form.
Parabola and line intersection plus distance. To find the intersection of the line and parabola, you must type them into your y-axis on your calculator. Once graphed, hit second plus trace, then go to intersection to find the intersections. Then use the distance formula you learned in the last slide to find the distance of the points that you found. So here you have x squared and 2x, and they intersect at 0, 0, and 2, 4. And then you plug them into your distance formula, and you find you get a radical. So just like the last problem, you want to simplify your radical. Linear programming. Linear programming allows you to find the maximum and minimum of a function within given constraints. Greater than sign means shade to the right or above the constraints and function, and less than is the same but to the left and below. The vertices created where all the shading touches is a solution to the problem. So here in this problem you have x is greater than or equal to 1, so you want to shade above. Here you have y is less than 2, so you want to, y is greater than, you want to shade this way for y. And then y is less than negative x over 2 plus 4.5, and you would want to shade to this side of this line. And you have your 3 vertices as your answer, which are right here.
So today in our Unit 1 we went over system of equations, system of inequalities, distance word problems, investment problems, distance formula, given a parabola and line, find the points of intersection and distance between the 2 points, and linear programming problems. Thank you, I hope this helped.